two lines that are intersected by our transversal are parallel lines, and I know that the lines are parallel because I can see these little red triangles on the lines. Our four types of angle pairs that are formed have something special about them. So let's go through it and see what those things are and then apply that knowledge. So our four types of angles we learned about previously were corresponding angles, alternate interior, alternate exterior, and consecutive interior. So here's what's true about each one of those kinds of angle pairs. If our angles are corresponding angles, what we know about them if the lines are parallel is that those lines or those angles are congruent to each other. So we're going to use that fact momentarily. Alternate interior angles, same thing. Those happen to be congruent to each other if the lines are parallel. Alternate exterior angles are also congruent when our parallel lines are cut by a transversal. And then you may see a pattern, but unfortunately it falls apart right now. Consecutive interior angles are not congruent. I can tell they're not because look, angle 3 and angle 5, one of them is acute, one of them is obtuse. There's no way they're going to be equal to each other, congruent to each other. But instead what's true is that those angles are supplementary, meaning they'll add up to 180. So make sure you make a note of that. The consecutive interior is that odd one out. It's the only one that's not congruent. It's supplementary instead. So let's use those four pieces of information to answer a couple questions. So first up, let's start with a basic sort of diagram that you'll see with these problems. We have two parallel lines cut by a transversal. We want to find the measure of all the angles. All we know is that one of them is 120. So degrees. Let's go ahead and find angles 2, 3, and 4 first. We can use that or find those using old knowledge. And it does say to explain our answers. I don't know that I'm going to write down my explanations, but make sure you're listening to my explanation and maybe jotting some notes down for yourself if you're going to forget. So let's start with angle 4. I know that angle 4 is also 120 degrees because I have vertical angles that are across from each other, and I remember that they are congruent. Next up, I know that angle 2 is going to be 60 degrees because these two angles right here make a straight line, and I know straight lines have 180 degrees. And then finally, angle 3 is also going to be 60 degrees. I can get that a couple different ways. I can see that I have another set of vertical angles. I could also use this straight line right there and know that 60 and 120 make 180. So those angles I can find using old knowledge. To get the new kinds of angles formed over here, angles 5, 6, 7, and 8, I'm going to have to apply some of those new types of angle relationships we just found. So let's start with angle 5. If I look at angle 5 and my original angle 120 degrees, I can see that those are corresponding angles, and from our new notes, I know that corresponding angles are congruent to each other. So that angle is also going to be 120 degrees. If I think about, let me switch colors real quick. If I think about angle, 2 and angle 7, I can see that those are an example of alternate interior angles, and my notes say that if parallel lines are cut by a transversal, then alternate interior angles are congruent, so these are both going to be 60. Let's see what else I might try. Let's go back to that original 120 degree angle and angle 8. Those are both outside of the parallel lines and they're on opposite sides of the transversal, so there's an example of alternate exterior angles, meaning those are both going to be congruent from what we just learned. And then if I want to, there's many ways to do these. Hopefully you guys are thinking, well, what about this? What about that? There's tons of different ways you can do these problems. I'm just kind of giving you one example. If I think about angle 6, maybe I want to use just these lines over here. They make a straight line, so angle 6 must be 60 degrees. Now you're probably looking at this and realizing we wrote the same two numbers over and over and over again, 120 and 60. And that's going to be the case with these. There's only going to be two numbers you write down, an acute angle and an obtuse angle, unless they all happen to be 90 degrees. So use that fact. I mean, there's only two angles that are being written down, and they kind of form a pattern. They repeat. So let's go ahead and try this one. This time, again, they give us just one angle. They tell us that angle 1 is 105 degrees and ask us to find all the other angles. So I'm going to give you a second to think about that. Try that. Go ahead and pause the video and try these angles, otherwise let the video play and I'll have my answers pop up in just a couple seconds. So there you can see the 8 angles. Again, notice there's only 2 angles that we used, either 105 if the angle was obtuse or 75 if the angle was acute. Now I didn't go through and write down all my reasoning, but hopefully as you were doing this in your head, you were at least telling yourself why you knew certain angles were what they were, either vertical angles or supplementary angles, or don't forget our new kinds of angles we have to use now, examples like alternate exterior angles. Notice they're both congruent. Same side interior angles, notice they're not congruent, but they do add up to 180 degrees right there. Alright, and then last up, let's go ahead and do, let's go ahead and pause this for a second. And now let's continue. Sorry, I couldn't find my examples. Let's go ahead and do a couple, remember I call them G-algebra problems that involve geometry and algebra to solve. So let's use our new types of angle pairs and relationships to find what these angles are. So first thing first, I want to identify what my angles are called. Are they alternate exterior? Are they corresponding? What name do they have? And that will dictate what equation to write for them. So for this first example, I can see I have one angle that's 115 degrees, one angle that's labeled x plus 5, and the first thing that I notice is I don't have a name for these kinds of angles. They're not alternate interior because this one's outside the angle. They're not consecutive interior because that one's also outside. So I don't have a name for them, so I need to maybe think of a different strategy. And what I can tell is that I'm going to find angle 4 first. I know that angle 4 is 115 degrees because I have vertical angles right there. So now that I know those two, let's just take a look at these two angles instead. I can see that those two angles are an example of same side interior angles or consecutive interior angles. And so what I want to do is look back in my notes and see what's true about those. Or go from memory. And from memory, I know that same side interior angles are not congruent. This was the odd one out. They are supplementary, meaning they'll add up to 180. So now that I know that I've used my geometry to kind of figure out what I'm going to do. I'm going to now write an algebraic equation to solve this. So I'm saying that my angles are going to together add up to 180 degrees. So my two angles are, in this case, 115 degrees. Oh, that's a really gross color. Let's get a different, better looking color. 115 degrees. I'm going to add that to my other angle, which is x plus 5. And I'll drop the parentheses because there's nothing to distribute. So there's my equation. I'm going to go ahead and just do some simple algebra to solve. So add up my like terms and have 120 plus x would equal 180. And then I'll subtract 120, so I get x equals 60. Now x is in an angle, so I'm not going to put a degree symbol on that. And all I wanted in this example was to find the value of x. But if it ever did say find the value of the angles, make sure you go back and plug that in to see if what your actual angle is. That may be a good way to check your problem, even if it doesn't say to do that. So for example, x plus 5 would get me, x plus 5, 60 plus 5 would get me 65 for this angle. 65 and 115 do add up to 180. So it's a good way to check and make sure you've done it right. All right, and then our very last one. Again, first thing first, figure out what kind of angles you're working with. So this one's exterior, this one's exterior, they're outside of the parallel lines. They're also on opposite sides of my transversal, so I know that these must be an example of alternate exterior angles. And that's the first part, but then remember, look back and see what that means. So parallel lines that are cut by a transversal, if I have alternate exterior angles, I know that they are congruent to each other, meaning they're equal to each other. So that'll tell me what equation to write. So my equation this time is going to be to put my two angles equal to each other. So 2x plus 1 has to equal 151. And again, I'll just do some simple algebra to solve that. I'll subtract 1 from both sides. So I get 2x equals 150. And then divide both sides by 2. So I get a final answer of x is 75. Again, x is not an angle, so I'm not putting a degree symbol on that. But now's a great opportunity to check, especially if you have some extra time on a quiz or test. So go back and plug in x as 75 and work that out, and you'll see that it does indeed work out to 151 degrees, meaning we were right, our angles are now congruent to each other.